Good morning, and thank you very much to Roger, to Mary, and to Curlew Action for organising this really useful and timely event. I'm Geoff Hilton. I work for WWT, the wetland charity, as the head of conservation evidence. And today I want to put Curlew Headstarting in a broader context, to zoom out and ask, what is the problem we're trying to solve with Curlew Headstarting? Why is it a promising technique? What are its limits and constraints? And what does all this tell us about when and where headstarting might be a good option for curlew conservation? Firstly then, why are we even talking about headstarting for curlews? This graph is taken courtesy of the British Trust for Ornithology's Breeding Bird Survey, and it shows the fundamental problem we are looking at: a rapid, large-scale and reasonably long-term decline in breeding populations of the Eurasian curlew. Now, this is for the UK, but these declines are widespread across Europe. So we have a very major conservation issue to address. And we know a couple of key factors about this decline. Firstly, we know that survival of free-flying birds, of juveniles and adults, is pretty high and has been stable over time. So there's little scope for conservationists to improve this part of the life cycle, this part of the demographic story of the bird. It's already good, it's already high. However, we also know that productivity, the production of fledglings and recruits into the breeding population, is low and has declined in the recent past. And so it's a logical focus for our conservation efforts. In the UK, we have a situation where the upland areas in the north of Britain primarily, northern England and Scotland, contain some large, rather continuous curlew populations, numbering potentially in the thousands of pairs. However, further south in England, also in Wales, also in Ireland, we've now got a situation where there are very small, somewhat isolated curlew populations, anything from a few pairs to a few tens of pairs. And so this means these populations are at substantial risk of extinction in the near term, and with that would come a substantial loss of the historic range of the species. So conservationists need to find actions, interventions that can improve productivity of these small isolated populations in the pretty near term. Now, we know that in the majority of situations, the reason for low curlew productivity is primarily high rates of predation on eggs and on chicks. Also problems with agricultural machinery and so on, and a range of other issues, but predation is the key one. So with this in mind, there are a number of conservation interventions that have been trialled with some success for curlews. These include nest fences, so just protecting the area immediately around the nest to keep predators and agricultural machinery off during incubation, larger scale fencing around whole breeding areas, diversionary feeding of predators to distract them from the wader eggs and chicks that are available for a limited period of time, lethal predator control, usually of foxes and corvids, but sometimes other species, and there are some innovative ways of deterring predators from wader breeding areas that are at least in trial stages. And of course, there is headstarting, which is, I guess, one more in this list of immediate interventions we can make to try and boost productivity in breeding curlew populations. So I'm just going to sort of try and outline, why is headstarting waders potentially useful for us? Well, if we think about a typical wader population, a typical female curlew, she will lay a nest with 4 eggs in the breeding season, and these 4 eggs will result in a healthy population, in a population that's breaking even in 0.6 fledglings at the end of the breeding season. Now, in a headstarting situation, that female rocks up at the start of the breeding season, she lays her 4 eggs, and we take them into captivity, put them in an incubator, and we hatch them ourselves, taking them out of the risky situation of being in the wild. We rear the chicks and we release them at or around the point of fledging. And typical success rates in head starting operations would mean that those 4 eggs convert into something like 3.2 fledglings rather than something between 0 and 0.6 fledglings. So you've created a massive increase in the number of fledglings produced per nest. So you can see that in principle, head starting can give a huge boost to the productivity of a breeding female curlew. But does it work in practice? Does it work in the field? Well, we're fortunate at WWT and with partners at our SPB and others in having a really good example of a head starting project that has gone right through from start to finish for a closely related species, the black-tailed godwit, in the fenlands of eastern England. And here we did a head starting operation, and we've shown that head-started black-tailed godwits will migrate appropriately to West Africa. They will have the sorts of high survival rates typical of a wild black-tailed godwit. They will have high phylopatry, so they will return to the area where they were released, and that they can be successful in breeding. And the graph shows the rapid increase in the population of black-tailed godwits at our site that resulted from our head starting operation. So yes, head starting of waders can work. It can work at an individual level for the head started birds, and it can work to boost small wader populations. So given those figures and the spectacular increase you can get in the productivity of a curlew as a result of head starting, you could ask the question, why don't we do this all the time everywhere? And so I just want to explore a little bit about the challenges and the constraints around head starting, which mean, although quite impressive, it maybe isn't appropriate in all circumstances. And the first thing to mention is that it can be quite an expensive technique. It can be quite difficult insofar as it relies on certain specialist skills in aviculture and biosecurity and veterinary skills and so on. And it can be risky in the sense that all your eggs are literally in some cases in one basket. So if there were to be a disease outbreak, if there were to be a fox get into your release pen, then you can lose the whole operation for the year. And that sort of risk doesn't apply, that all or nothing risk doesn't apply for things like nest fences. That said, we have never, in all the years we've been head starting several different wader species, we've never had a catastrophic failure of the whole operation in a year. So it's possibly more hypothetical than real. Perhaps a more significant constraint is that there is a limit on the numbers of waders you can head start in a reasonable logistical operation. And I always think it's really useful to refer back to a point made by Graham Appleton, a well-known wader expert and blogger, who said British curlew need to fledge 10,000 more youngsters every year just to arrest the decline in numbers. We've got 50-odd thousand pairs of curlews in the UK. That's where that number 10,000 comes from. And you can see we can't be head starting 10,000 wader chicks per year. So there is a limit to the scope of wader head starting, of curlew head starting. And I've just illustrated this limitation on the numbers with this graph here. So if we look at the productivity of a failing curlew population that's fledging about 0.2 fledglings per pair per year, you can see the number of fledglings produced as a function of the population size. And this higher line shows what it would need to get to in order to reach stability. So that gap is what we've got to fill, and we could potentially try to fill with head starting. And if the population size was 500 pairs, we'd need to be releasing about 125 fledglings to bridge that gap between reality and where we need to get to. If the population is 1,000 pairs, it needs to look more like 250 fledglings. If the population is only 100 pairs, you might only need to top it up with 25 fledglings. Now, these are pretty optimistic numbers, actually, because I'm assuming here that it's 0.2 fledglings per pair is the reality. Some UK populations are worse than that, but also it's kind of assuming that a head-started juvenile curlew, a head-started fledgling curlew rather, is kind of equal in value to a wild fledgling, that they will survive as well and that they are as likely to return to your target population as a wild bird. And we don't yet know if that is actually the case for curlews. So it might be that you need more head-started birds to cover sort of the deficit in their quality, their ability to survive and return. Another rather fundamental challenge to headstarting of curlews and waders is that headstarting doesn't really resolve the underlying causes of the decline. It's what you might call a band-aid, a sticking plaster on the decline, which is caused by ecological problems, which result in very high densities of predators and so on, which results in low productivity. And the consequence of that is that when you stop headstarting, and remember headstarting is relatively expensive and difficult, the decline will simply resume again unless something else has changed in the meantime. Another challenge worth mentioning is that headstarting will fix a curlew population, right? You take curlews into captivity, you rear them, you release them, possibly you're going to boost the curlew population. It doesn't bring any wider conservation benefits in the sense of it's not a habitat improvement. Other wader species are not beneficiaries, and that challenge, that limitation doesn't apply to some other interventions we might take for curlews. But I think is really important when we talk about these challenges, risks, constraints, limitations on headstarting, and people often do, is that we go back to that list of interventions I brought up at the start and consider many of these have exactly the same challenges, limits and constraints. So things like nest fences, side-scale fences, predator control, they are also expensive. Some of them also require some pretty specialist skills. Lethal predator control is a skilled professional operation. Fences requires skilled field workers that can find curlew nests and put up a nest fence without causing too much disturbance. All of these things are difficult to deploy at a really large scale. Again, difficult to deploy when your population is in the many hundreds or thousands of pairs, relatively simpler if your population is a few tens of pairs. Most of these solutions don't solve the long-term ecological problem, the problems with habitat and the way that we have too many predators. Some of them help a wider suite of species, some of them only help curlews. And the one thing headstarting does have in its favour is the scale of the impact per capita, per individual pair. As we've said, we are increasing productivity of a head-started curlew pair by, in the region of 500 to 1,000%. And that magnitude of impact isn't quite the same for some of these other interventions. Now, that's not to say headstarting is way better than all these interventions. Of course, it's not. It depends on the circumstances. But it's just to point out that some of the criticisms of headstarting and its limitations apply equally to the other solutions we have in our toolbox. So headstarting is potentially extremely powerful, but it also has some limitations. Given all that, when and where do we think we should headstart curlews? And we've kind of arrived at a few different scenarios. One is to buy time for a small declining population, and that's what this central graph, or this left-hand graph, is showing. A population that's gradually declining. It's already very small, 15 pairs at the start. Headstarting can give it a significant boost in a relatively small period of time, and that will buy you 10, 20, 30 years in which to fix those underlying problems. Those underlying problems haven't gone away, but if you hadn't headstarted, you might have lost the population entirely before things had started to turn around with the wider ecology. The other potential option is to accelerate the recovery of a small population where you've already kind of fixed some of these problems. The population is starting to be productive, but it's absolutely tiny. It's a few pairs, and we've faced this situation with black-tailed godwits. Then you can kick it out of this extreme bottleneck with a bout of headstarting, especially if you can get the eggs from somewhere else, and get it up to a sort of viable population scale of a few tens of pairs, whereupon natural increase starts to look more significant. It can also be used as a technique to bring curlews back to areas that were formerly suitable. Population was lost, where they've been restored, habitat's been restored, good management is now in place, but the curlews aren't necessarily coming back of their own accord in timely fashion because there aren't many juvenile curlews kicking around these days. So 3 broad scenarios: buying time, accelerating recovery of small populations, recolonizing newly suitable areas. And thinking about headstarting, as I've said, it's a band-aid, it's a sticking plaster for some longer term problems. When should we do it? Well, stating the very obvious, we should do it when it's the optimal conservation decision to do so. It is not in a different category to other conservation interventions. It has strengths and limitations like those. We should pick headstarting above other options when it is optimal to do so. And ultimately that decision comes down to, we are trying to boost productivity. Which method, which potential intervention that we have in our toolkit will give us the most birds recruiting back into that population for the least cost? That really is the equation we're trying to work out here. But of course, because it doesn't solve these underlying problems, we need to only consider headstarting when it's part of a wider recovery plan for the curlew population, so that there is a longer term future beyond a period of headstarting. So a few closing thoughts. Headstarting can be a very powerful tool for curlews in some circumstances and as part of a wider recovery process. And it needs to be considered objectively alongside other options. And I guess final thoughts. What I haven't really touched on today is, does headstarting for curlews work? We've shown that it works for godwits. I think a lot of the talks over the next 2 days are going to cover the evidence we've got about what works and what doesn't work in regard to curlews. But for sure, there's a lot we don't know about the effectiveness of curlew headstarting and about how we might optimize the technique to keep getting to that situation where there are more recruits per unit cost than we currently have. So therefore, I would really urge all projects to, whilst doing headstarting, gather the evidence about what's working, gather data that we can use to get better at this technique, and then share that evidence so that we all improve as a conservation movement and make this technique as good as it can be. So thank you very much for listening. I hope you have a really good session in the next hour or so, and I hope you have a really good workshop in the next 2 days. Thank you.